Hi, I'm Max. I'm an official lens creator for Snapchat, and I'm also a full-time AR developer based in Amsterdam. I have a background in visual effects for film, which has some interesting similarities with making AR lenses for Snapchat. One of them being the material graph editor. In Lens Studio, you can make your own materials, which are basically the shaders that you put on the models in your scene to render them. And I think there are a lot of cool ways to make your scene look a lot better, purely by using the material graph editor. So for this demo, I'll be going over some cool techniques that you can use, that you can kind of reuse and mix for your own projects. And this is the scene I'll be having a look at. It's this Sakura tree, so it has this growing animation, and the leaves on top, the canopies in the tree really look like very dense. Like there's a high count of flowers and leaves in there. And then there's also the water with the reflections and the leaves on top deforming along the waves on the water. Those are all things that are done purely in the material editor. I don't have enough time to go over the whole scene, but I will go over the density of the flowers at the top of the tree. So just the canopies with the kind of, they feel very bushy, they feel like they have lots of layers in them. And that's all done in material. And I will also go over the reflections in the water and just making it look like water in general with the waves and everything. And then the project files for this whole scene will be available at the end. So if you need any specific information, if you want something, if you really want to deep dive into it and see how I set up certain effects in the scene, you can just check the link and download it for yourself. So let's open up the first project file for the canopies in the trees. So I've got this empty project with lighting and camera, but I do have the assets already. So that's the canopy mesh, which is just, I'll show you what it looks like. It's just half a sphere. Let's see, let's just scale it up. So it just looks like this. It's just like the top third part of a sphere, and it's got UVs on it. And then I've also got this texture. So it's this texture for flowers. It looks like this. It's just a very low resolution, 128 square pixels texture that I just quickly put together in Photoshop. And this we're gonna instance or like loop on top of the mesh multiple times. So we're gonna randomly rotate it and randomly position it and do that on top of this half sphere mesh so that it looks like there's a lot of flowers in there. So yeah, let's make a empty material just for the graph material. So you're gonna need a graph empty. And then in the mesh, let's select that one. This one, I'm just gonna rename it to canopy. So now in that material, let's immediately just grab the texture, just a texture 2D parameter node, which will grab any texture that you give it, and then I'll rename it to flowers. So now in this material, we can just select with the flowers texture, we can just select our texture file for the canopies. And as you can see, it's working, but it's way too big, so it doesn't look right. We want to scale it down. Now the easiest way to scale it down is just, instead of having it use the UV coordinates of the mesh, just grab custom coordinates, and then you can input any coordinates into it. And then I'm gonna grab the same coordinates again, the UV coordinates of the mesh. And then plug it in there, except now we can, of course, edit them in between these two nodes. So I'm just going to add a scale node, scale coordinates, and then I'm going to set that value to, I think, 4 or something, just so that it's a lot smaller. So that worked, except it's now also repeating the texture, which is not what we want. So to get rid of all the duplicates of the same texture, just make sure that the coordinates don't go over 1 or below 0, because that's what's happening here. So I'm gonna add a clamp node. So, and then you've got just one instance of the texture, and everything else is just black. So that's good. Now, what I want to do for this texture is copy it like a few times and then randomly rotate and position it on this mesh. So to do that, I'm gonna add a loop node, so that I'm gonna loop all of these nodes that happened before it. Just gonna add a loop node in here. and then connect that to the shader. So now it's going to loop everything that's before this node. And why I want to do that is because I want to, along with scaling it, I also want to rotate and position it, and then give it random values for rotation and position based on the current loop number. So I'm just going to loop it like 5 times or something. And then the final image that it's going to produce is going to be the maximum value for each pixel. I think that sounds about right for doing it with leaves. This kind of depends on what you're doing with it, but maximum sounds good. So let's firstly give it some random offset for each loop, because it's already doing the looping, but you can't see it yet because they're all identical, so they're all just on top of each other. But I'm just going to add an offset node, and that will offset it in the X and the Y direction. So I want to make a random value for X and a random value for Y, which is dependent on the current loop. So I'm just going to add a loop iteration node, which gives us the current number of the loop we're in, and then plug that into a random noise, and that will be for X. So let's set the scale to 1, by the way, because we want every value to be a unique new number. So this will just give us 0 to 1 values for each loop that there is. And I'm going to do the same thing for the Y direction. So I'm just going to copy it and connect it. And then to make sure that these inputs are unique, I'm going to add just any number in between here. Something that's higher than the amount of loops that we're using. So like 10 or something. Doesn't really matter. So now these two seeds for the random noise are unique. So the random noises themselves will be unique. And then we can combine them back into a vector too. So let's say construct vector. That way it becomes a coordinate instead of just 2 separate numbers. So I'm just going to disable the input 3 and 4, and then you just get coordinates. Now these random noises are between 0 and 1. So that means they can only go to the right or up. But we also want to go to left or down, which means I'm going to remap them to, instead of 0 to 1, which is the input, go from -1 to 1, and then it can go in all directions. So let's input that into the offset coordinates. And as you can see, the texture is now placed randomly on the sphere in different positions. And the amount of textures is of course the amount of loops that we're doing. So we can just make this 10 or 20. But for this case, I would say 5 is fine, because later on we're gonna do something else to make it feel very volumetric, and then you don't want to have too many loops in it because that also eats up performance a little bit. So let's just keep it at 5, and let's also do rotation, because I can still see a little bit of repetition in there. You can still see that little flower at the bottom right of the texture every time, which is not good. We want to make it more unique, more like less repetition in there. So I'm just going to add a rotation node, rotate coordinates, and then I'm going to do the same thing I did with the offset coordinates basically. So I'm just going to grab the loop iteration, make a random noise again based on the loop iteration, set it to 1 by 1, and then this will be 0 to 1. The rotation takes a 0 to 360 value, because 360 is a full rotation. So I'm just going to multiply this by 360. And I'm also going to make it unique again. So I'm going to, because right now these two have the same inputs. The X for the position offset and the rotation have the same input. So I'm just going to add some number, let's say 20 to it. And now we can be sure that none of these seeds will ever have the same value. So yeah, if you plug this into the rotation node, it works. There's not really any way to tell that it did, but it does look less repetitive. So if you now just up the value in the iterations of the loop, let's see what that looks like. Let's set it to like 50 or something really high. It has to load for a little bit, but that definitely looks like random rotation and position. There's nothing repetitive going on anymore. So let's just keep this at 5. And let's have a look at how to make this more dense, how to get that multiple layers thing going on. So the first thing we need to do is make sure that there's transparency in there, because if you have multiple layers, you want to be able to look through the layers. Of course, you want to see the layers behind it. Right now, it's not transparent; it's like black solid, so it's completely opaque. To make it transparent, you could set the blend mode to normal, but I personally kind of avoid using blend modes if you don't have to. It's heavier on performance, but also you get this occluding effect. You can see it in the blue thing in the background. It does that in your lens as well, and it just occludes meshes behind it that also have transparency. And you can fix that by doing the depth test, disabling the depth test checkbox, but these are all kind of things that if you don't need to do that, then it's better to not do it. So in this case, there's actually a way better system to do it. So you can just disable the blend mode, leave it at this, and instead add a discard node. So what discard does is it completely pretends like the mesh isn't even there. So if you just set the discard node to 1, then it will completely remove the whole object. It will just pretend that it isn't there, and it's not even the blending mode, it's just not rendering it at all. So we can do this per pixel. So we can just grab the output of the loop, and then with a swizzle node we can get the alpha channel. So let's have a look at the alpha channel. You can just type A in there for alpha, and then you get the alpha. And then we can check if the alpha channel is less than 1 actually. Just some value that's not opaque anymore, but that should be transparent. So let's say less than 1. And then if it's true, it will discard the pixel. And as you can see, it's definitely discarding it. It does look a bit weird with the hard edges. So I'm gonna set the is less to a lower value, like 0.7, maybe 0.6. I'm gonna go for 0.7. And then as you can see, it does the same thing as blending mode. It's just one problem is that you don't have the feathered edges. So you could combine this with a blending mode if you like, or just use blending modes anyways. But I have noticed that for this particular case, it doesn't really matter. You don't need to blend the feathered edges. So I'm just not gonna do it. I'm just gonna leave it at this. And that's nice, because now we have transparency in a way without using blending modes. So that's a good trick for that. So now that we've got one layer ready, we kind of want to make multiple layers of these. And the usual way to do that would be to do prefab instancing, for instance, or just manually duplicating the mesh in the scene. But that's a lot of work. So instead of doing any of that, I'm gonna do the instancing in the material. So you've got this instance count integer over here. It's set to 1 by default. It's just doing 1 instance of the material. But you could set it to like 50. And then you don't see the difference just yet, because just like with the looping, it's doing it 50 times, but it's all identical on top of each other, so you don't see the difference. But it is doing 50 iterations of this material. And that means that with an iteration ID node, an instance ID node, you can get the current number of the instance that you're in. So what I'm gonna do here with this instance ID node is I'm gonna move the mesh a little bit for each instance randomly in some direction, and then merge all of those back together so that you can see a lot of layers on top of each other. And the good thing about that is that's all done in the material, which means it's rendered on the GPU of your phone, and that's a lot cheaper in performance than doing prefab instancing. So if you can use material instancing, definitely use it instead of prefab instancing. So what I'm gonna do is just grab the current position of the surface. So that's just a world space position, and I'm gonna plug that into the world position vertex of the shader. And nothing will change yet, because that's the default that it always goes back to if there's nothing plugged in. But now, in between these two nodes, we can add something. So I'm just gonna add some value. Let's see, I'm just gonna plug that in there, and then in this add node, you can, for instance, move it to the right a little bit by changing the X value. As you can see, it's just moving the whole thing all together. Or you can move it up or down or backwards or something. So that's pretty cool, but we want to do that individually per instance. So I'm gonna get the instance ID and I'm gonna make 3 random numbers based on this instance ID, which will be the X and the Y and the Z direction. So I'm just gonna make a random noise node, set it to 1 by 1 again, and then let's copy that noise 3 times and connect it to the instance ID. And I'm also gonna add random values to the second and the third input just to make them unique again. I'm just gonna say like 100, and then let's add another one and make that 200. So now we've got 3 random values between 0 and 1. I'm gonna construct a vector of them again. This is kind of the same as we did with looping the texture. So just construct a vector 3 this time, because we have X, Y, and Z direction. And then I'm gonna remap it, because this is still 0 to 1, and we want it to be -1 to 1, so that they can also move to the left or down or back. So I'm just gonna remap the 0 to 1 value to -1 to 1. Now if we add this to this original surface position, you can see something is happening. It's not very clear what it's doing, but that's because the distance is too small. So we can just multiply the total thing that we're adding to the surface position by some value, just a single value, let's say 10 or 20. And then you start to see that it's really like getting very like dense. It's got a lot of layers, and it feels a bit volumetric, because it's moving the whole mesh 50 times. And you can of course do more instances, you can do 100, but I think 50 is fine for now. I mean, having more instances definitely eats up performance as well. So that's looking good, but there's still a lot of repetition in there, because you can see that it's the same texture for every layer. So we're gonna go back to the texture looping all the way at the start, and you've got this loop iteration node, which told the position which random number to pick for randomly offsetting or rotating the texture. So I'm just gonna add the current instance iteration to that. So I'm just gonna add a node, just replace it for all of these 3 inputs, like that. And now in this add node, you can just add an instance ID node, and then you get a random texture for each instance. So that's a super easy way to make it feel random. Now, if you want to have more canopies in your scene, because you have a tree with a lot of branches and you want to make it random per branch, then it would be really easy if the current position that it's in would determine the random seed for all of these offsets. And that's actually a very easy thing to do as well. So you can just add another input to this add node, let's say 3 inputs. And then let's make a transform node. So a transform node just picks the current world position for the given object position. So the given object position is 0, 0, 0, and it returns the world position for that value. So that means if you just plug this into the add node and then move it around, it will immediately update the random seed every time you move it. So now you've got a canopy that you can place on multiple places on the tree, just duplicate it in the scene, and it will immediately pick a new random flower arrangement kind of thing. So that's a good way to create non-repetitive textures in your scene. Now, of course, there are many ways to make this look better, to give it more like better lighting and everything, but for now I'm afraid there's not much time to do that. So I'm gonna go over to the next thing, and that's the water with the reflections. Again, if you wanna see more in detail how to set this up, or if you wanna see my continued work on this one specifically, just check out the project files that I'll give at the end of the video. Because in there I've worked on it a little bit further, and it's more developed there. So let's go to the water scene. So this is the scene for the water. It's not completely empty. I've already got this cube in there, which will be our testing cube for checking if the reflection works. And then I've got this grid of planes. So that's 9 by 9 planes, and each little square is one plane. I'll show you the mesh for that one. It's just a pretty high poly count plane. It's got 9,000 triangles in it. And to keep the size down, I've decided not to put any UVs or normals in it. It's only got position information. And I've set the position information to be half float. So if you press this change vertex attribute format button, you can actually set for each of the attributes in your mesh, you can select if you want it to be full float data or if you want it to be half float. And that drastically reduces the size of your mesh in some cases. So it's definitely worth checking out if you don't need the full precision, if you can do that, because it really helps keeping your lens under 4 megabytes. So this grid of planes I made because I don't want to make one really large plane with a lot of polygons in it, but I do need a plane as big as possible with as many polygons in it as possible. So I just made a script that instances, prefab instances this plane. So this water prefab is just an empty scene object with a mesh renderer for the plane in it. And then it instances it in a grid of rows by columns. So I can just set 10 by 10 or 1 by 1 or 5 by 5. And I think 9 by 9 is fine for this case. So yeah, you've just got a bunch of planes and they all have the same material on it. So we've got the surface position, it's showing the object space right now. Let's remove that so that it's just a white plane. And let's start off with making the reflections in the water. So the way I did the reflections for this lens was getting a custom camera, a second camera for the reflections, and then having the camera do exactly the opposite of what the user camera does. So if this is the surface of the water, then the user camera would be looking at the water like this, and the reflection camera would be looking at the water like this. So it's like scaled upside down. Like you're scaling it to -1 in the height, and then you just get this value, this angle to look at things. And then whatever this reflection camera is recording, I'm projecting onto the water surface from the user's camera, from the user's perspective. And that's actually all you need. So it's pretty easy to set that up. You can just make a second camera. I'm just gonna call that reflection. And then first we're gonna need to mimic the movements of the user camera in local position. So I can't add a surface tracker to this reflection camera like I did to the user camera, because that's gonna update it in world position. But I need to copy the local position of the user camera to the reflection camera. And the local position you can just very easily get using a script. So I made a very simple script for that. Just copy transform, it's called. And if you open it, this is what it looks like. It just sets the local position based on the user camera local position. And then it sets the rotation based on the user camera rotation. And it does that on every frame. So that's all it does. It's a really simple little script to write, but you can just grab it from the project files at the end. So let's drag that onto the reflection camera, and then it asks you which object to match. So match object, we're gonna match the user camera object. And now the user camera and the reflection camera are identical in local space. So I'm just gonna add a empty object, which will be the anchor for the reflection camera, because we're going to scale the reflection camera upside down. So I'm just going to call this reflection anchor. And I'm going to put the reflection camera in there. And this reflection anchor, we can now just all together in the viewport, you can actually see it. You can just scale it upside down altogether. So you can just do this and you can see that camera flipping upside down. Don't look at what the preview window is doing, that's not interesting yet. But the camera in the viewport is flipping upside down. So I'm gonna set that to -1. And then the reflection camera is still doing its thing with the copy transform, but it's doing that inside of a reflection anchor, which is scaled upside down. So once we've done that, let's actually make sure that the reflection camera is not recording anything else besides the object. So the clear color option, I'm gonna set that to color so that it's got a solid black background. And then what we want to do is give the reflection camera its own render texture. So instead of rendering to the render target, I'm going to copy over the render target and just make a duplicate of it and then call that reflection target. And then let's select that in the camera. So now this reflection camera is completely on its own. It's just doing its own thing and the reflection target isn't used currently, so it's not doing anything. By the way, we can reduce the resolution of the reflection target quite a lot because I'll explain later why that is, but the reflection will not be used in its full resolution in this case. So we can just set this use screen resolution, we can disable that, and then set the resolution to 512 by 1024 or something, which is like half the average smartphone screen resolution. And that will definitely help your performance as well, if the camera doesn't need to render every pixel, but only 1 and 2. So yeah, I'll get back to that later, why we can do that. So for now, let's just project this reflection target onto the water mesh from the user camera. So I'm just going to make a texture in the water material and call that reflection texture. And then I'm going to give it custom coordinates instead of using the UVs on the mesh, because the mesh doesn't have any UVs and we want to project it from the current user position. So I'm just going to drag that in there. And then projecting it basically means grabbing the screen coordinates, because that's what the user is currently seeing. So you can just make a node called screen UV coordinates and then drag that in there. And as you can see, it's already having absolute screen coordinate positions, so that purple black grid is completely, it's not sticking to the surface of the water. So now I'm just going to go to the material of the water and select our reflection render target. And there you go, you've got a reflection of the cube. There's some things are off though. Some things need to be fixed. One of them is that the cube seems to be inverted. And the reason that it's inverted is that we scaled the camera upside down. We did -1 on the scale of the camera for the reflections. And that means that it will not render the back side of the meshes, but the front side instead. So if you go to the material that's on the cube, which is the simple PBR material, which is one that I made really quickly, you'll need to do this for every material in your reflection. You can set the cull mode to front, which will invert this, but then of course the non-reflected cube will be inverted. So let's set it back to back, just like it was. And then you can set it to two-sided, so it will render both sides of the mesh. And in that case, it will look fine. So now it's looking like an actual reflection. And you can actually rotate it and everything. It's just a proper reflection like it should be. There's still a little bit of a delay in there, as you can see when you rotate around it. The reason for that delay is the render order of the cameras. So it's rendering the render target first and then it's doing the reflection, which will be used in the next frame. So we're gonna drag this reflection to be rendered first, so that it's doing the reflection first and then it's doing the user camera. And then you can see that it's completely static, it's on the same frame. So this looks a lot better. Yeah, so let's move on to do the water itself, the waves in the water and the look of the water as well. I'm gonna start off by making a Voronoi noise. So Voronoi noise is a very organic kind of noise. It generates pseudo-random values, but it looks very like natural. So it's a very easy node to make natural effects with. And I'm just gonna blend that with the reflection that we've already got. So I'm gonna say that the Voronoi noise will be the base and then the reflection will be blended on top of that. And the blend mode will be like something like screen. So we're not seeing the reflection right now, and the reason for that is that this reflection texture doesn't have an alpha. We can just add a swizzle node, which is kind of it's a very easy node to do any text-based just managing channels in your color. So Right now it's outputting X, Y, Z, W, and W is the alpha channel, that's the fourth one. So this is basically like RGB-A for alpha. And we can just replace the W with a 1. And then it will have a full alpha channel. So the alpha channel will be 1 everywhere. And we still don't see it, but that's because the Voronoi noise is very dark. If I disable it and make the color black, you can see that the reflection is in there. So now let's add that Voronoi noise again. And let's set the scale of the Voronoi noise to something really small, like 0.1. Of course, we still need to give it a seed. The seed will be the position in world space of this plane. So I'm gonna get the X and Z positions of this plane, because it's laying down, so we need the X and the Z directions. The Y is not interesting. So I'm gonna get a position node. World space is fine, and then grab another swizzle node. And instead of X, Y, Z, W, we're only interested in X and Z. So just type that and then hit enter, and then you can drag that into the seed of the Voronoi. And as you can see, that's looking like some organic kind of noise pattern. So I think the scale can be a little bit bigger even. So let's do 0.05 by 0.05 or something. And then it starts to look a bit like water, except it's not moving yet. So you can do that with the offset. You can actually scroll through the offset. And you can see that it's moving. So let's add a time elapsed or elapsed time node, and that will give us a value that's constantly updating and giving us the current time since the lens has started. So I'm just gonna add that to the offset, and then it's slowly animating. I'm gonna multiply it a little bit, and that looks more like a water kind of movement. I think it can go a bit faster even. So the next thing we want to do is make these into actual waves. So let's go to the vertex position of the shader. So the shader has a color input, but it also has a vertex position input, like we used with the canopies earlier. And you can just grab the world position and select it and plug it in. So this will not change anything, but now we can add anything in between here. So let's just split this world position into the 3 components that it has. So that's an X, Y, and Z component. So I'm just going to split it, and then I'm going to construct it back into a world position again. So I'm going to say construct and just drag the same input to the same output, and then plug that in there. And now we can change each component individually. So we can just edit the Y component and add some value to it, for instance. Let's just drag that in there. And let's say 10, and then it moves the whole plane up by 10. So that's kind of what we want, except we don't want to do that with a static number, but we want to do that with the output of the Voronoi noise, because wherever the Voronoi noise is a higher value, we want the plane to be higher so that it looks like it's a wave moving. So I'm just gonna, instead of 10, set that back to 0, and I'm gonna add the output of the Voronoi. So just add that noise in there. And it does already work, but it's just a very small effect, it's tiny. So I'm gonna multiply whatever is coming into that add node by, let's say, 10 or 20. And there you go, that's actual waves. So that's pretty cool. The reflection isn't reacting to the waves yet. The reason that the reflection isn't doing that is because this shader node, it calculates the vertex positions first, and then it calculates then it does the fragment shader, as it's called. So that's the colors and the per pixel shader. So that means that it's first doing the deformations of the waves, and then it's getting the screen UV coordinates, which are not deformed at all because the vertices are already in their position. So we actually want to do these 2 nodes. We want to do that before we're going into the fragment shader. We want to do these 2 in the vertex shader, and then go into the per pixel shader. And there's a node for that. It's called the interpolate node. You just make it, and it assumes that every node on the left of this node is vertex data, and then every node on the right is fragment data. So if you plug that in between, then you'll see that it starts to deform along with it, because it's now calculating the screen UV coordinates before doing the wave in the vertex. And then after that, it moves the vertex up for the wave, and then it deforms the screen UV coordinates, which is used for the texture. So that's how you get the deformations in the water. Yeah, so let's make it look a bit more like water. For instance, by maybe we can use the Voronoi noise in a mix as the ratio, and then just make two color values. One will be for the high colors and one will be for the low colors, so like deep water or waves. So I'm gonna connect them to the mix, and then this one will be the deep colors. So I'm just gonna set that to dark blue or something. And this one will be the high colors. So I think something like white or turquoise would be good. Yeah, I'm just gonna plug that in. And there you go, it looks a bit more like water. I think I can make it look more like water by adding a power node to the Voronoi. So that means that it's the fall off of the Voronoi noise will be a bit sharper. So if you just increase that, you get this kind of, yeah, that definitely feels more like a water kind of situation. So I can change this color a little bit to make it feel better. And the deep color can be a bit brighter. Now to make it interact with lighting, we need a PBR node, of course. So let's add that all the way at the end. And that will look a bit strange at first, partly because there are no normals on this mesh. So that's an important thing to remember. I removed all of the normals that are on this water mesh tile. So if you want to add normals in the material, you can actually do that. It's called an override node. And if you add it and then plug it in, you can actually override a bunch of things, and everything before this node will assume these values instead of the values that it's reading from the mesh. So you can override the coordinates or the tangent or the normal or the position even. So those are all interesting things. Let's just add a float value for the new normals that we're giving it. And that will be a vector 3, because a normal is a direction in 3 dimensions. So I'm gonna make it XYZ. I'm gonna call this new normals. Now the new normals are gonna be pointing up, because on a flat plane, all the normals can point up. So that's an easy one to do. So I'm just gonna add 1 in the Y direction, and then it's pointing upwards. I'm gonna drag that into the override. And that looks a lot better. That looks like it's actually doing some real relighting stuff. So yeah, let's just change some parameters in the PBR, like set the metallic all the way up and maybe the roughness, so that it kind of matches the lights. Let's see if we can find the lights. There's the light over there. I think it looks better if we do something like this. So yeah, that's very basic how to make water look good. Of course, in the final project files it will look a lot better, so definitely check them out. And that's all the time I've got, I'm afraid. So I really hope that you learned something new today and that I maybe inspired you to use the material graph more often. This is the link to the full project files, by the way, it's on the screen right now. And yeah, see you next time. Thanks for watching.